Hey guys, welcome to 13.2. Today we start talking about permutations and combinations. So the big thing to remember about permutations is that order is important. And for combinations, order is not important. All right, so permutations, it is important. Combinations, order is not important. And then here's our learning targets for today. So a permutation is an ordered arrangement of R objects chosen from N objects. And here's the notation, and here is the formula. Now you can also just type this in the calculator, right? If you don't want to do it the formula way. So how many ways can this class vote for a president and a vice president of the club? So first let's figure out how many people we have in our class, and I will tell you that we have 31 students in our class. And then how many different objects are we choosing? Well, we're choosing two, right? A president and a vice president. Okay, so R would be 2. And this is a permutation because the order does matter, president versus vice president. Okay, so either in the calculator or by manipulating this formula, you are doing 31p2. And if you want the formula, that would be 31 factorial over 31 minus 2 factorial. And another way to do it, I'll show you all the ways, we could do 31 factorial over, this is 29 factorial, but 31 factorial is really just 31 times 30 times 29 factorial, all over 29 factorial, and then these could cancel, so in the end, it's just 31 times 30. And that's going to be, 930 ways. Okay, but if all that didn't make sense, you could literally just type this in or this in straight away. And we should probably go over that. So you're going to type in 31 and then go to Math, Probability, option 2, and then just hit 2. Okay, so see how we got the same answer? And then you could also just type this in too. The factorial button is option number 4 on the probability part. Okay, lining people up. Again, order does matter if you're counting different ways to line people up. So this will be a permutation as well. You have 5 people lined up, so that would be in 5 different places. So if you want to use permutation, in this problem, n would be 5. And R would also be 5 because you're putting 5 people in 5 different slots. Okay, so this one could be 5p5. And you can either write it out or type it in the calculator. Turns out whenever they're the same number, actually, let's type this in. 5 math, go to probability, option number 2, hit 5 again, you end up getting 120. But feel free to do it whichever way you want. Now there's another way to do this problem. And it's basically the same as the counting principle that we learned before. You could just make like 5 spaces for the 5 people and say, okay, well for the first spot, you could have 5 choices of people. And now that that can't be repeated because that person's taken, they're just going to go down by 1 each time. And this is another way, if you multiply across, another way you can get 120 as the answer. Okay, so that's just that multiplication principle. Okay, the birthday problem. It says Shannon, Patrick, and Ryan have all different birthdays. What are all the possible ways this could happen, assuming there's 365 days in a year? Okay, so again, a permutation because the order does matter because different birthdays would be different different order of birthdays for different people would be different possible ways. So in this problem, N would be 365 and R would be 3 because you're choosing 3 birthdays out of 365 days. All right, so one way to do it, it would be 365P3. All right, so I'll get that going here. That would be a really big number, 48228180, comma, comma. All right, that's the answer. But again, another way to do it by the multiplication principle, if we have 3 spots for the different amount of birthdays, the first one would have 365 options, then the second person would only have 364, and the third person would only have 363. That would be another way if you multiply those to get this answer. All right, so those are all permutation order matters. Now let's jump into combinations where order does not matter. Okay, and here is the formula for combinations. It's very similar to permutations, except you're dividing by an extra r factorial. Okay, so a combination, order doesn't matter. Are objects selected from n distinct objects without repetition? Here's the formula. All right, so listing combinations. List all the combinations of A, B, C, and D taken 2 at a time, and order doesn't matter. So like A, B is the same as B, A. So let's do it by hand first. If you're picking 2 at a time, you could pick A and B, you can pick A and C, or A and D, or B and C, or B and D, or C and D. Okay, those are all the possible combinations. Again, if you reverse the order, same thing. So it looks like we have 1, 2, 3, 4, 5, 6. All right, so 6 total combinations. Great. Another way to do this is by using C4, 2. All right, so we can plug that in for N and R, because out of 4 objects, choosing 2 at a time, that would be 4 choose 2. All right, so in the calculator, you could type this in as 4 choose 2, which is a new button, or you can use this formula, 4 factorial over 4 minus 2 factorial times an extra 2 factorial. Either way you guys want to do it, hopefully we get 6, but let's see. So 4, go to math probability, option 3 now, because this is a combination. And then we're hitting 2, and you get 6. All right, so a lot of ways to do these problems. Okay, let's flip it over. And here is the back side. How many different committees of 3 people can be formed from a pool of 7 people? Now, we're not giving them titles like president, vice president, secretary. So this would be a combination where N is 7 and R is 3. All right, so you're going to be doing 7 choose 3, or that formula if you'd like. All right, so this would be 7, math probability, option 3, 7 choose 3. And you end up getting 35. But again, you can also plug it in the formula. Okay, this one says, how many ways can a committee consisting of 2 faculty members and 3 students be formed if there's 6 faculty members and 10 students eligible? Okay, so we've got 2 situations here. Again, it's just a committee with no titles, so it's definitely going to be a combination. The first combination let's do for faculty. So for faculty, out of 6 members, we're choosing 2. So 6, oh gosh, why did I write that so big? 6, choose 2. And then for the second option, we're going to multiply by the student options. So for the student options, we have 10 students. We're choosing 3. So 10, choose 3. And then you're just going to multiply those by the multiplication principle. And let's see what we get. So 6, choose 2 times 10, choose 3. I got 1,800 as the final answer. All right, so not that much harder, just 2 different situations, just multiply. Okay, forming different words. How many different words, real or imaginary, can be formed by using all the letters in the word rearrange? Okay, so this one, we have some repeating letters, right? So let's figure out, kind of off to the side a little bit, how many of each letter do we have? So we have 3 R's to choose from, and we have 2 E's to choose from, and we have 2 A's, and then 1 N and 1 G. All right, so this will be a combination, right? How many different words can be formed using these letters? All right, so 1, 2, 3, 4, 5, 6, 7. Okay, so there's 9 letters total. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so let's say we want to start with R. So out of the 9 possible slots, we have 3 spots to count for an R, right? So for the R's, it'll be 9, choose 3. But now that 3 of those spots are taken by an R, doesn't matter where, now how many spots do we have left for an E? 2, 3, 4, 5, 6. So now we have 6 spots to choose 2 of the E's. And now we're down to only 4 spots left to choose an A. So 4, choose 2. And then we're down to 2 spots left to choose an N. And then finish it off with 1 spot left to choose a G. All right, so you're going to go across and multiply all of these combinations. All right, so let me slide this up a little bit. All right, so we have 9, choose 3, times 6, choose 2, times 4, choose 2, times 2, choose 1, times 1, choose 1. And that's 15,120. Okay, 15,120. And then, you know what? We'll do this on the next one. Okay, and then the last one here, arranging flags. How many different vertical arrangements are there of 8 flags if 4 are white, 3 are blue, and 1 is red? So notice this is a very similar problem, right? We have 4 whites, 3 blue, and 1 red, and we want to find all the different combinations of arrangements we could make. So one way to do it is the same way we did the previous one. There's 4 white, and there's 3 blue, and there's 1 red, and we're trying to fill 8 flag spots. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can just go ahead and do it the same way. I do want to show you guys another way to do it. There's another formula for n objects that are not distinct for a permutation. So we're assuming the white flags and the blue flags and the red flags are not distinct from each other. They're just like all the whites are the same, all the blues are the same, all the reds are the same. So I'm going to give you another formula if that's ever easier. So if you ever have a permutation with n objects not distinct, and this would have worked for this problem as well because the r's are not distinct, the e's are not distinct, you can use this formula as well. N factorial over n sub 1 factorial times n sub 2 factorial times as many as there are up to n sub k factorial. All right, so for this problem, I'm going to try this formula and see what happens. So we have 8 flag spots to choose from. So 8 factorial. And then n sub 1 would be how many white? 4 factorial. N sub 2 would be how many blue? 3 factorial. And n sub k would be how many reds? 1 factorial. And this will be another way to get the answer unless you would rather do it this way. All right, so if we type this one in, we'll make our fraction. It's 8 factorial is option 4 over 4 factorial times 3 factorial times 1 factorial. And you get 280. But again, you could have done it just like we did the previous problem as well. But that's only a permutation with n objects that are not distinct. All right, thank you guys for watching.